events. So the sample space can be donated by all of these symbols. Okay, the symbols is not really like, when you see those symbols, you need to know that represent a sample space. So what is sample space? Sample space include all the outcomes that is possibly to take for a trial of experiment. Okay, so for that experiment, that's the sample space. You know all the outcomes. Okay, all the outcomes will be listed in this. Okay, so it's the set of all possible elements or objects considered in a particular situation. This is called universal set. Okay, universal set. So a Venn diagram illustrates how all elements in the sample space are distributed among the events. So basically, we have Venn diagram. In year 10, you have like two circles or 3 circles. The 3 circles can be a little bit complex because you have A only intersects with B, B only intersects with C, C only intersects with A, and there's a set in the middle which is A intersects B intersects C. So that's a more complex case. But today we're not going to talk about that. Okay, that's a case which is more complex. There's 3 events and then they have intersections between each other and they have a common thing in the middle, so which is intersection of all of them. And we have this outside is not A, not B, and not C. So you have A dash intersects B dash intersects C dash. So we are not going to talk about the 3 circle situation too much. Just focus on the 2 circle one. We have like this one. So there are some elements we need to know. So this one is A dash intersects B. This part is A intersects B dash. So it's called A only and B only. This is B only. This is A only. And the middle is A intersects B. Okay, the middle is A intersects B. And all this circle here, okay, all of this red part is A union B. Or another notation can be A dash intersects B dash and dash. Okay, where's A dash intersects B dash? Outside is A dash intersects B dash. Okay, outside is A dash intersects B dash. So not this bit, is the other bit. So is another dash. Okay, so it's the complementary set. Okay, complementary set. So normally we'll use A union B to represent. Okay, we normally will use A union B to represent. Or this bit, the outside can be represented by A union B dash. Okay, not A union B. Okay, not A union B. A union B dash. So that's some notation. Okay, that's some notation for the Venn diagram. You need to know when I say A dash intersects B, where is it? Okay, where is it? The next definition, there are a lot of definitions. A non-set or empty set is the set with no elements in it. We use a symbol like empty set, okay, nothing in the set, or often we use this symbol, okay, that's represent empty set. Like commonly we use that symbol. We don't really use the curly bracket with nothing in it. It's a little bit weird. So we use that one. That is an empty set symbol. All elements that belongs to both A and B make up the intersection, which is A intersects B, which I said that's the middle here. All the elements that belong either to A or B or both is the union set, which is A union B. Okay, either in A or B is the union set. So you need to know the key words. If I said and, that gives you intersection. If I said or, that will give you the union. Okay, that's like quite 99% of the time is true. Okay, when I say and, it's an intersection. When I say or, it will be a union set. Okay, the next one is a very important definition. Okay, the next one is very important definition. 2 sets are mutually exclusive. Okay, mutually exclusive. So what is mutually exclusive? It has no elements in common. Then we use a symbol to represent is A intersects B is empty set. Okay, nothing in the intersection set. So no intersections. Then A and B are mutually exclusive. If we use a Venn diagram to represent this case, we can have a set A and a set B. In this case, A and B are mutually exclusive because there's no intersections between that. So must remember mutually exclusive. A only is A intersects B dash. Okay, belongs to A and not belongs to B. Okay, the intersection means and. Belongs to A and not belongs to B. So you will have this part. Okay, this part, the yellow part. Okay, is A only. Only belongs to A, not belongs to B. And another thing is N bracket A. Okay, N bracket A. It represents the number of elements in A. Okay, number of elements in A. So if I say set A equals to 1, 3, 5, that's set A. So the number of A equals to 3. There are 3 elements in the set A. So just count how many elements are there. Okay, 3 elements. NA equals to 3. NA is not a probability. NA is not asking you to list out the outcomes. NA is asking you how many outcomes are there in the set A. Okay. Because last year I do the test, I find like students don't understand what this N means. They always list out the elements for me. Okay, it's not asking you to listing them out. It's asking how many are there. Okay, the number. And then we have like one rule is called the additional rule. Okay, additional rule is the union. Okay, probability A union B equals to probability A plus probability B. Subtract the probability A intersects B. Because probability A plus probability B, you have include the middle section twice. Okay, you have include the middle part twice, so you need to subtract it. So you have to learn this. I'm not really talking about that too much. So just remember this rule: A union B equals to probability A plus probability B. Subtract probability A union B. A intersects B. Sorry. But if A and B are mutually exclusive, A intersects B will be 0. Okay, there's an empty set. Then the probability of getting the intersection is 0. Okay, nothing in it. Number of intersection equals to 0, then you have probability equals to 0. So probability A intersects B for mutually exclusive set is the number of elements in A intersects B over the number of total elements in the universal set. Then you have 0 elements in that. I don't know how many total. Let's say we have C of that. But that will give you 0. Okay, I don't really know how many I have in total, but I know that will be 0 because the numerator is 0. So the probability A intersects B equals to 0. Therefore, you have like the A probability A union B equals to probability A plus probability B, and subtract A intersects B, which is 0. So for mutually exclusive, that is just A plus B. You can see there's no intersection, so you just add everything only once. So you don't need to subtract anything down. So that's some basic rules for it. And we use Venn diagram to think about the other questions. We have a survey of 100 university students. A market research company find that 70 students own smartphone, 45 own cars, and 35 own both smartphone and cars. Use a Venn diagram to help you answer the following questions. So you will have 2 events. Okay, events of car, let's say smartphone, and events of car. So I have 100 students in total. You always start from the intersection. So 35 own both. So you will have 35 here. And then you have, look, you have 70 students on smartphone. So in the smartphone set, you should have 70 in total. Have 35 in common, then you have 35 got smartphone only. 45 on cars. but 35 of them have both, then you will have 10 in this one. But this set is not completed because I don't have the here, okay, the outside bit, okay, the S dash intersects C dash. So I will have like 30 plus 35 plus 35 plus 10 equals to 80. You have 100 in total. Therefore, outside will be 20. Okay. Outside, not get a smartphone or a car. Okay, no smartphone or a car. So you have 20 outside. So, question A. How many students own neither a car nor a smartphone? 20 students. Part B. How many students own either a car or a smartphone but not both? But not both. So it's S only and C only. Okay, S only and C only. So it's 35 plus 10 equals to 45 students. Okay, it's quite obvious. Okay, this case is quite obvious. Okay, example 2. Let the universal set be 1, 2, 3, 4, 5, 6, where the outcomes are equal likely. Okay, you have same chance of getting 1 to 6. If A equals to 2, 4, 6 and B equals to 3, what is the probability of A union B? So let's have a think. What is A union B? A union B is 2, 3, 4, 6. 2, 3, 4, 6 is A union B. Then the probability of A union B will be the number of elements in A union B over the number of total. That gives me there are 4 in the set. The number of elements in A union B, there are 4 elements in it. And the total number of elements is 6. Okay, the total number of elements is 6. So it's 2 over 3. The next one is asking, what's the probability of A intersects B? So let's find the intersection set. There's empty set. Okay, A intersects B, nothing in common. 2, 4, 6, 3, nothing in common. Empty set. So the probability of A intersects B equals to 0. In this case, A and B are mutually exclusive. Okay, A and B are mutually exclusive. They have nothing in common. And probability A dash. Okay, probability A dash. So it's 1 minus probability A. That's 1 minus, how many elements in A? 3. How many elements in total? 6. And that equals to a half. 1 minus a half gives you a half. D. Probability B dash is 1 minus probability B. That equals to 1 minus 1 on 6. That's 5 on 6. Okay. Example 3. Suppose that in a certain school that the probability of students play soccer is 0.18, the probability that the students play tennis is 0.25, and the probability that the students play both is 0.11. Find the probability that students either or both play either of both of these sports. So the Venn diagram not only can represent numbers, it can also show the probability. So if it shows the probability, then the whole set will be 1. Okay, the whole set should add up to give you 1. So again, I'll start from the middle. The middle have 0.11. play soccer or tennis. So you have 0.11 in the middle, and the students play soccer is 0.18. So you have 0.07 in this case. Okay, 0.18, you have 0.07. And you have students play tennis is 0.25. Okay, so you have 0.14 in this case. 0.25 minus 0.11 give you 0.14. And then you need to find the outside. So 0.18 plus 0.14. Okay, you have 0.32. So the outside will be 0.68. Okay, not playing a soccer or tennis. Not playing soccer or tennis. Okay, actually it's asking either or both. If you say either or both, then this is the union set. So you find the probability play soccer, union plays tennis. I want the union set. Okay, either this or both. So that equals to probability S plus probability T subtract probability S intersects T. You don't really need a Venn diagram. I just want to show you the Venn diagram. So you can use this formula to actually work on this. Okay, so it's a union. You need to know what you want to achieve. Okay, I want to find the probability of the union, and I have formula. Probability S, probability T, subtract the intersection. So that is 0.18 plus 0.25, subtract 0.11. Okay, that's 0.32. So it's the same as this event. Okay, you add those three numbers, 1, 2, 3, those three numbers, you have 0.32, which is the same here. Okay, 0.32. Okay, either use the Venn diagram or use this formula. I think save some time if you directly use this formula. That's for example 3. Okay, the next one. The next one is probability table. Okay, probability table. So it's called a Carnot map as well. So we normally call this a probability table or two-way table. Okay, probability table or two-way table. A probability table is an alternative way to a Venn diagram when illustrating a probability problem. Okay, so I think this is better than Venn diagram because it's quite explicit. You can directly calculate all the values. In Venn diagram, you still need to think, okay, which one belongs to which part and which I should put. This one is more explicit than Venn diagram. Well, when you can use a Venn diagram for like two events probability, I think you can use a two-way table as well. So I will try to encourage using this one more compared to Venn diagram. So this map can only represent the numbers, can also represent probability. So you have two events. So you have A dash A and A dash, B and B dash. So the last box will all represent the total number of A, total number of A dash, and total number B, total number B dash. And then the right corner, it will represent the total number, okay, in total, how much you have, how many students you have. For example, the previous university question, you have 100 here because you have 100 students in total. You have 100 here. If it's represent probability, then this just be 1. Okay, here just be 1 because the total probability is 1. Okay, it doesn't matter in which case, the total probability will be 1. So we have 1 here. And all the 4 boxes in the middle, they are the intersections. Okay, A intersects B, A intersects B dash, A dash intersects B, A dash intersects B dash. The 4 number represent intersections between two events. And if you have add vertically, that should give you the last number. If you add horizontally, that should give you the last row's number. Okay, last column's number. So let's have a look for the example. I think this table is quite good because I see in VCA exam there will be 3-mark questions and it's purely based on using this table. Okay, so there will be some questions directly related to the table. A barbecue attended by 50 people, hamburgers and sausages were available. It was found that 35 hamburgers and 38 sausages were eaten, and 6 people were not to have eaten neither a hamburger nor a sausage. So 6 people eat nothing. If no person ate more than 1 hamburger or 1 sausages, find the probability that a person chosen at random. Okay, so you have 50 people. 35 hamburgers were eaten. So 35 must be 35 people eat 35 hamburgers because no one eat more than 1 hamburger or a sausage or 1 sausages. So if I can set up this table. It's a 4 times 4 table. So I'll have H dash, sausage dash, and the total number must be 50. That's something fixed. I'll use a black to write the fixed number. So 50 is the fixed number. 35 hamburgers were eaten. There must be 35 people who eat hamburgers. And 38 sausages were eaten. There must be 38 people eat sausages. And 6 people not eat neither hamburger nor a sausage. So it's not S, not H. Okay, the intersection with not S and not H. That should be 6. That should be 6. And then I can complete the other part of the table. Then I will have, okay, that must be 15. That must be 12 because you subtract them. Okay, subtract them. And when you have those two numbers, I can calculate the next stage. 12 minus 6 will give you 6. That minus 6 will give you 9. Okay. And then when you write those two red numbers, okay, you should know that 35 minus 6 will give you this box, and 38 minus 9 will give you this box as well. So this box will be 29. Okay, this box will be 29. But after you put this number down, you need to check it, okay, vertically and horizontally. So 29 plus 9 give you 38, 6 plus 6 give you 12, 35 plus 15 give you 50. Add vertically, 29 plus 6 give you 35, 9 plus 6 give you 15, 12 plus 38 give you 15. Which is correct. Okay, this table is correct. Okay. Let's have a look at A. A hamburger or a sausage, but it doesn't mention not having both. Okay, so for A, is the probability of hamburger union sausages. Okay, a hamburger and a sausage, or both. Okay, so 3 situations: 1 hamburger, 1 sausage, or 1 hamburger and a sausage. So that will be 50 minus 6. Only 6 people eat nothing. Okay, only 6 people eat nothing. Then all the rest must consume any hamburger or sausage or both of that. So 50 minus 6 divided by 50. Okay, it's asking you the probability. Wait. That's 44, so 0.88. Part B, a hamburger and a sausage. If it's and, it's H intersects S. Okay, H intersects with S and the sausage. So it's 29 over 50. .58. Only 1 serve of the food. It's probability of H only, union S only. Only 1 serve is only H or only S. What would that be? Only H or only S will be the 6 or this 9. Okay, H intersects S dash give you H only. S intersects H dash will give you S only. Then those two numbers will be only one hamburger or only one sausages. So it's 15 over 15 is 0.3. D, only a hamburger, so it's hamburger only. H only will be, okay, H intersects S dash, which will be 6 over 50, 0.12. Okay, everything will be read from the table. Yeah. Well, it doesn't matter. It doesn't matter. You can keep as fraction as long as it's the simplified form for fraction. That's fine. Okay, no problem. Okay, so everything can be read from the table. Okay, so let's have a look in the Venn diagram. In the Venn diagram, this one will be H intersects S. Well, let's put it in Venn diagram. Well, I'll just put it here. Well, you don't really need to do that. I have no space. Well, if that's H that's S, you will have, in the middle you will have 29. Okay, in the middle you will have 29. Well, I shouldn't use this color. So you will have 29 here. Then you have H only. H only will be 6. S only will be 9, and the outside will be 6. The middle phone number actually gives you the Venn diagram. Okay, the middle phone number actually gives you the Venn diagram. So you can convert Venn diagram into two-way table or two-way table back to Venn diagram. Okay, example 2. In a recent survey of senior citizens, we found that 85% favor giving greater powers of arrest to police, and 60% favor long sentences for convicted person, and 50 favor both. Okay, 50 prefer both. What percentage favored at least one of those two? So if it's at least one of those two, it can be both. Okay, can be both. So let's set up this table. When you see there's something talking about two events, that will be two-way table. Okay, you will use two-way table. So let's say we have P dash, long sentences dash. Then we are talking about probabilities. Then the last number must be 1. Okay, here must be 1 for sure. 85% favorable great power to police, so that's 0.85. 60% want long sentences, this will be 0.6. 50% favor both, so 0.5. Okay, what I can have is 0.35 for that, 0.4 for that, and 0.15 for that. And then we have 0.1 for that. And I can see, doesn't matter which way you calculate it, it always gives you 0.05. Okay, always give you 0.05, and you can add 0.5 plus 0.1, 0.6, 0.35 plus 0.05, 0.4, 0.85 plus 0.15, 1. And vertically 0.6, 0.4, 1, 0.1, 0.05, 0.15, 0.5, 0.35, 0.85. So which is correct? And A, what percentage favor at least one of those two? So at least one of those two is asking the probability of the union set. Okay, it's ask the probability of the union set. Then it's just 1 minus the 0.05. Well, don't like any of them. Okay, I don't like not that, not that. So 0.95 will be the union. So just exclude the intersection, the L dash intersects P dash bit. What percentage favor neither? So it's the probability P dash intersects L dash, which is 0.05. Okay, neither will be 0.05. Okay, that's all for D and E. So that's where we're up to for our exam. Okay, we will finish F and G later, like after our exam.